Okay, so we know from day one in talking about cones how to make a hyperbola, but the definition of a hyperbola is that any point on the actual hyperbola, if you measure to one focus and you measure to the other focus, that with ellipses it was sum, with hyperbolas it's difference, that difference is constant. So here's the definition. The difference, and what does difference mean in this context when I say the difference of? Like what mathematical operation? Subtract. So the difference of the distance to two fixed points. And what are we going to call those fixed points? They're the focus. Plural focus points. That's usually what I use, although you can call, there's other words. All right. So let's talk about A, B, and C. A, B, and C mean the same thing as they did with ellipse. And you can even look on your blue card to see that. So make sure you're on the side that says hyperbola. So this is going to be on the back side from where we were. So what is A? Look on your card if you need to. The distance from what?
Center to vertex.
The distance from center to a vertex. And remember, there are two vertexes. We call them vertices. All right, and so what that would mean, I'm going to kind of color code this to make it a little bit easier. The A could be side to side, and it could be up and down. And that was true when we did ellipses as well. All right, so what is B then? It's the distance from center to co-vertex. Okay, and so you notice with hyperbolas, the co-vertex is not actually a point on the parabola. It's just there to help with the framework. And when we go over an example, I'll kind of explain that. All right, now with ellipses, A, or A squared, was always the bigger number because vertices were always further apart than co-vertices. But with hyperbolas, A could be smaller than B. You could have a hyperbola whose vertices are really close to the center and co-vertices really far from the center. But what do you notice about the two formulas about A, or where A squared is? It's on the left, or we should say maybe it's first, okay? So let's note that somewhere. A is first. It's not always the biggest, okay? That was true for ellipses, not true for hyperbolas. Okay, let's talk about a focus. Oh, there was a blank for us to put that in right there, and I forgot. Okay, what is C? The distance from the center to the focus. Okay, so look at where this focus is. And I'm going to kind of draw this slightly above. See how C is bigger than A? That's different also from when we did ellipses. So the focus is still inside the hyperbola curve, but it's further away from the center just because of the way the hyperbola is. I like to describe it as like the hyperbola is almost like an ellipse, but it's blown apart. Okay, like a bomb went off in the middle and it blew it apart in either direction. All right, we do have a formula for C squared. Look on your blue card. It's a little bit different than the one from ellipses. A squared plus B squared. What was the formula for ellipses? A squared minus B squared. Man, that would be so easy to get mixed up. Good thing we have a formula card. And then A is always first. Okay? So that's where we're supposed to write that down. So what is the big difference between horizontal and vertical hyperbolas? Well, where the vertex and the focus are. If they're horizontally aligned with the center, okay, then it's a horizontal. I want you to notice for horizontal, the x term is first. With ellipses, x was always first. But look over here at vertical. See how y is first? That's how you know whether it's a horizontal or vertical. And again, this is all easy to get mixed up, but you're going to have all these formulas. So let's go ahead and practice a problem. All right, and as far as how to find the center, that's going to be the same as what we did before. Okay, the only difference is if y is first, then you got to account for that, but that's not what's happening here. Okay, how do I even know this is a hyperbola, by the way? What's different about this from an ellipse? It's a subtraction sign. And again, that's on your formula card. So that's how you're going to, like, once we start combining all these, that's how you're going to know. Do you think this is a horizontal or vertical hyperbola based off of the fact that x is first? It's going to be a horizontal. So my curves are going to be horizontally aligned. Okay. So the center. We got really good at this with circles and ellipses, and it's going to be very similar. +2, -1. And so you start by graphing that point. Okay, since before, this is kind of a hard habit to break, but before A would have been from the bigger number, here A is from the first number. So A is going to be 3, and because it's underneath an X, I'm going to go to the right 3 and mark that vertex, and I'm going to go to the left 3 and mark that vertex. In essence, I'm adding and subtracting 3 from my center. So you can either graph it and then write down the points, or you can figure out the points and then graph it. Okay, so what about B? If b squared is 16, then b is 4. And because that's underneath the y, I'm going to go up 4. 1, 2, 3, 4. And that's going to be a covertex. And I'm going to go down 4. 1, 2, 3, 4. Okay, we actually have enough information to go ahead and graph it. So I'm going to actually graph it first, and then we'll do the focus points, okay? To graph these, you may remember this from last year, you may not. You're going to make a little box. You see how I'm kind of making a box? It could be a square, but usually it's a rectangle. Making a box, and I'm connecting vertices and covertices to make that box. Just do that really lightly with your pencil, or do it dotted like mine. And what this box does is it helps you figure out where the asymptotes are in this problem. So look at where I'm starting with my pen here. I'm starting in the center, and I'm going to go to the corners of the box. Because hyperbolas have an interesting thing. They have slant asymptotes. Remember with rationals how we had to do long division to find those slant asymptotes? Well, we don't have to do that here, but we still have them. And then what you're going to do is you're going to go through your vertices close to your asymptotes, just like kind of how we treated asymptotes before. And if you notice this curve, it's horizontally. There's a left and a right part, okay? And that is because X was first. And I knew that. I predicted that at the beginning. And so that's a way you can kind of check your work as you go. I'm going to do one quick thing. I'm going to put the V's on the inside. I'm just doing this because for the next part, I want to make it really clear what we're doing. All right, so the focus points are going to be on the inside of these two curves. So whatever C is, it should be more than 3. Okay, and so we use the formula. C squared equals A squared, which is 9, plus B squared. So with ellipses, we subtracted those two numbers. With hyperbolas, we're going to add them, but we get the formula, so we shouldn't be getting them mixed up. 9 plus 16, that's 25. So what is C? 5. Which direction are we going to go from the center? Left and right 5. 1, 2, 3, 4, 5. And we're going to write those points down. So this was a nice problem to start off with because it was in standard form and everything turned out to be a whole number. We know that's not necessarily how it will always happen, but pretty much every problem will follow the same format. Okay, so on example 2, it's not in standard form. We got to get it in standard form. Now, for both circles and ellipses, it was all about getting the x's together, getting the y's together, and so on. But look at there's a 4y squared and a minus 9x squared. This is telling me that the positive term should be what's first, because I know there should be a minus in between. So for this problem, I'm going to actually put the y squared term first because it's positive. All right, and so that means I need to write minus 8y next. I'm going to leave a space, and then I'm going to group the x's. So whichever, between y squared and x squared, whichever one is positive, that's the one you put first. Okay, what next? What did we do with ellipses with these numbers here? This 4, we don't want the 4 there, so we factor it out and we use parentheses. So that's going to change this negative 8. If I factor or divide out a 4, I now have a minus 2. And what you need to do somewhere is take that negative 2 and go through the process. Half it, box it, square it. The very last number is what you write to complete the square inside these parentheses. And then before I do anything else, I want to go ahead and balance it out. If this were a scale, how many pounds did I add to the left side when I wrote that plus 1? It wasn't really 1 pound. How much was it? 4 pounds. Because it was inside parentheses being multiplied to the 4. So 4 times 1. So to balance that out, I'm going to add 4 to the other side. Do the same thing to both sides. Okay. So what am I going to factor out of the next group? Negative 9. And I need to make sure I factor that negative out. And I want that negative there for hyperbolas. It's good to have the negative there. But what's 36, positive 36, divided by negative 9? Negative 4.
Isn't that 36x?
Yes, it was. Thank you. So we should have negative 4x. And if you're not sure you did that right, just do a quick distribution in your head and make sure you get what you started with. Okay, so what number am I gonna start down here to do completing the square? The negative 4, the number in front of that x. I know it's a lot of steps. You know how it gets easier? You just practice it a whole bunch. It gets easier and easier and easier the more you practice it. Half it, box it, square it. So plus 4 completes the square. And before you answer my next question, I want you to really think about it. When I put in that plus 4, what did I really do to the left side? I subtracted 36. Why subtract and not add? Because of the negative. This is the first time we've seen this because this is the first day of hyperbolas. So negative 9 times 4 is negative 36. So I'm going to do the same thing to the other side. All right, so we have 4. And by now I've totally forgotten what the number was. This is why we box, because it's easy to forget. So I boxed that negative 1, so I'm going to go y minus 1 in parentheses squared. That's what completing the square does. It writes it into something squared. Okay, next we have x, and then go to the box, minus 2 squared. And then you got a little bit of number crunching to do. And you should be able to do this without a calculator. So go ahead and figure out what is 68 plus 4 and then minus 36. If you think of it like money, sometimes that makes it easier for whatever reason. If you know it, shout it out. 36. Seems like we should be done because we've done an awful lot of work right here. But remember the standard form, it doesn't equal 36. It equals 1. This is the same as ellipses. So we need to divide by that number so that I only have a 1. That means I got to divide everything so that I keep it balanced. So when you're trying to figure out, well, what does this do? Just do 36 divided by 4, and that number goes on the bottom. There's a minus. That's good, okay? Because this is supposed to be a hyperbola. If it wasn't a minus, then we wouldn't know what to do. Okay, let me give everybody a chance to get caught up. And I want you to be thinking, what type of hyperbola is this, and what is the center? It's a vertical one. How did you know that? The y is first, so this is definitely going to be a vertical, so it'll look something like this. And that means our center is going to be a little different. Watch what I'm going to do here. We haven't done this yet. You're not going to write 1, 2. You're still going to write 2. See how it's next to the x? That's the x value of the center. All right, so that's kind of weird. But once you've seen it a couple times, it'll be easier. We didn't have to worry about this with ellipses because x was always first. Okay, so let's plot that point. Okay, what about a? Remember, a squared is always first. So a is 3. And because it's underneath a y, I'm going to go up 3, 1, 2, 3. And I'm going to go down 3, 1, 2, 3. And those are going to be your vertices. So go ahead and write down those coordinates and see if you can come up with co-vertices as well. Okay, so what'd you guys get for the vertices? 2, comma, -2, and 2, comma, 4. All right, B. B is right there, it's 2. We're going to go left and we're going to go right. I hope at this point you're kind of like, this part's easy. Getting it into standard form, that's challenging, depending, some problems more so than others. But I'm hoping that once you figure out standard form, in knowing A and B, you can get these points. If you're still struggling with this part, I would strongly suggest you try to come in for tutoring so I can help you. Maybe explain it a different way or something. Whoops, not 0. 1.
How did you get 2, -2?
So I just looked at the points. 2, -2. 2, 1, 2, 3, 4. Essentially what you're doing is adding and subtracting 3 from the 1 value. Subtract 3, add 3. Since we were going up and down. Okay, anytime we're talking about focus, we got to use this formula. C squared equals A squared plus B squared. Now this is not a very pretty number, but we've dealt with this before. What is square root of 13 about, by the way? Or what is it between? It's between 3 and 4. So if I'm going 1, 2, 3, I'm just going to go just a little bit further to get the focus. Now I'm kind of working this problem in a slightly different order, but I wanted to go ahead and get all these points. And when you're writing that down, remember, you're just going to go 1 plus or minus root 13. 1 plus root 13 gives you the focus up here. 1 minus root 13 gives you the focus down here. Okay, now to actually draw, you're going to just go through, oops, wrong way. You're going to go through your vertices and your co-vertices. So if you haven't drawn this box yet, go ahead and do that. It doesn't have to be perfect. It's really just a framework for the next part, which is your asymptotes. Make sure your asymptotes go through the corners of the box right through the center. They don't have to be perfect, but they need to clearly be through the corners and through the center. Remember, we said this was vertical, and we can see now why, because my vertices are on the top and the bottom. And we can also see that the focus is inside the curve. That's going to happen with these hyperbolas. Okay. Last problem. Just looking at this, is this going to be a horizontal or vertical hyperbola without doing any work? How do you know it's going to be horizontal? The x squared is the positive term, and the y squared is the negative term. That's also how we know it's even a hyperbola. If this had a plus here, that would have been an ellipse. So remember, you're going to get those terms together. So this minus 36x, I'm going to get that over there and leave some space everywhere else. Let's see you. Let's see you. Give me a thumbs up or thumbs down. How do you guys feel about the very next step here? Like, what do you know what to do this next step? Can everybody, this helps me help you. I got like one thumb up and one thumb down. So I'm like, I have no idea. Okay. All right. So with this group, to do completing the square, I don't want 6x squared. I just want x squared. So this is why we factor out the 6. And so then factoring out is just like dividing. So negative 36 divided by 6, that's negative 6x. It's like undistributing. This works because I can do completing the square with this information. The way we do that is we take this number, negative 6, and we half it, we box it, and we square it. And that last number, which is squared, is what we write here, and we call that completing the square, because this is now going to be x, and this is why we use the box, x minus 3 squared. If I had like multiplied out x minus 3 times x minus 3 and did the double distribution, it would be the same as this trinomial. This is just a method for us to get the problem in the form we like. So in all that discussion, we forgot to balance it, or not forgot, but we hadn't yet. So if this is a scale and I'm adding 9 pounds, okay? It's like I'm adding 9 pounds inside of a bag, and that bag is always 6 times whatever the weight inside is. So 6 times 9, that's 54. That's what you have to add to the other side to keep the equal sign true. If you don't put 54, if you put another number, then the equal sign doesn't work anymore. Okay, over here on this one, very similar. I want y squared. I don't want negative 7 to be attached to that y squared. So that's why we factor it out. And when we factor it out, we got to factor it out from both things. And factoring out is just like dividing. So 14 divided by negative 7, that's negative 2y. And negative 2 is the number I go over here and do the half it, box it, square it thing. I will tell you, no matter how many times I explain this, it's never really going to make sense to you unless you practice it on your own. Okay, the last number, 1, that's what I add to complete the square. And remember, you got to say, okay, times negative 7, that balances it out. So I have y, I look at the box, minus 1 squared. And when I'm looking at something like this is what I think of. I like to combine these numbers, maybe say negative 12, and then look at it like this, 54 minus 12. You've been adding and subtracting numbers forever, but if what you're doing is working for you, great. If it's not working for you, this is something you could try. So 4 minus 2, 5 minus 1, 42. 42 is interesting because it's the same as 6 times 7. Remember, we saw this work out a lot like this with ellipses. Okay, so that completing, that whole factoring and completing the square, I get, that's tough. You have to practice it. You have to practice it, figure out what you're getting wrong, try it again. All right, what about the next step? We want to divide by 42 because we want that right side to say equals 1. And the way we can get that is to divide by 42. And you want to just take those two numbers, you want to divide them, and you want to write that new number in the denominator. Same thing here. 7 divided by 42, that's 6. And I can see now, since this is a horizontal hyperbola, the center is kind of like the standard, like how we even did with ellipses. So if you know the center, shout it out. Man, that was so enthusiastic. I'm just kidding. I know, everybody's tired. Okay, vertices. All right, we need to know A and B. And you know what? 7 and 6 are not, they are not perfect squares. I actually want to show you how you can do this, and I'm not even going to graph this one. Not because I should, it's good practice, but I want to show you how to come up with these numbers without even graphing, because I think for some of you, this could be eye-opening, that you can even do this without graphing. Okay, remember A is always first. 7 is not a perfect square, so we're just going to write square root of 7. Since it's underneath the x, we're just going to add and subtract it to the x value of the center. So 3 plus or minus root 7, and then the y value stays the same. What about B? Square root of 6. It's underneath the y, so add and subtract it to the y value of the center. I'm doing all this without even using a graph, and you can do this with whole numbers as well. And then c squared would be a squared plus b squared, that's 13. So the question is, am I going to add and subtract root 13 to the 3 or the 1? Focus always lines up, whether you're doing ellipses or hyperbolas, it's always going to line up with vertices. So we're going to do that to the x value. Okay, that's how you can find the information without even graphing. Okay, so this is what the graph looks like when you're completely done with this. One last thing that you'll need for your homework is just to make sure you understand a couple more words. And that is, here we go. Okay, this right here is your transverse axis. You may see that on your homework. And then your conjugate axis is right here. So the big difference is vertices. Obviously can't spell that and talk at the same time. We'll talk more about this in tomorrow's lessons, but the transverse is the axes that, you know, kind of cut your hyperbolas in half, like through the curve, and the vertices. Conjugate is through the co-vertices. In the past, this is how I've had students Remember this. Transverse is like vertices. Conjugate starts with a co, just like co-vertices.